my name is Sarah Hagan and I am a 10th grader at Cape Elizabeth High School. I have created an app called Physics Phone a Friend as an educational tool to help kids with physics. The move to remote learning during the coronavirus pandemic has happened fast and has been really hard. With shorter and fewer class periods, teachers can't get as much done as they would have, and the lack of face-to-face interactions makes it harder to understand some concepts. Since there is a lot of uncertainty about when remote learning will end, I think there is a need for lots of new online tools and apps, especially for science and math. And so I decided to start with a tool to help kids with physics at home. When I took physics last year, the kinematic equations were one of the first things we learned, and they served as a crucial building block for the rest of the year. If a student were to struggle with those, it would make the rest of the year really hard. As a result, that is where I put my focus, and I have built a calculator to help students with them. The audience for this is any middle school or high school student trying to work through physics at home. The objective of the app is not to be used as a device for kids to cheat on at-home quizzes and tests, but instead to allow students to check their homework and see step-by-step answers to their individual problem to help them learn to do it in the future. The core of the app is the calculator itself. It is relatively simple to use, and all you have to do is select which of the variables you know and which you don't know using the radio buttons, and then type in the known values. Then you click Calculate. Say perhaps you didn't provide enough values or left something blank like so. You will receive an error message that explains to you where you went wrong and when you try and click Calculate. You can also reset the values that you have typed in by clicking the Reset button at the bottom of the screen. If everything is typed in correctly and you click Calculate, you will receive a prompt asking you if you got it right or not, along with the answer. If you got it wrong, by clicking No, you will see a page or two detailing how to get the answer using your specific numbers. I think that having your numbers helps since it allows you to visualize the process better. From there, you can get back to the calculator anytime you want. Say you get the next problem right. You will then be shown this encouragement page. As you can see, from there, you can access the jokes. These jokes are one of the additional features to try and make the app more fun and engaging for students. It has 20 cheesy physics jokes that it will randomly select from and put on your screen. The purpose of this is to allow students to take a short break without leaving the app and doing something else which could potentially get them sidetracked. In addition to the jokes page, this app has a basic explanation page that allows students to quickly remind themselves what the equations are and what they are for. Throughout the app, this image of a dragon holding a lollipop can be found. Also, many of the explanations are written as if they are specifically talking to the reader. The reason for both the dragon and the personalized messages is to give the app a persona so that the subject and the app feel more informal and friendly versus the formality of most textbooks, which can seem unappealing and intimidating. I learned many things while developing this app. For the most part, I code only for robotics, so this was a new experience for me. One of the crucial things for it was strings. In robotics, you have almost no need for strings, since it is more about actions. So I had to learn a bunch about those, such as how to insert variables in along with text in order to create the answer explanation. I also learned about the onEvent command. These were crucial to the coding because most of the actions of the app are based on the actions of the user. One of the hardest things about making this app was accounting for all the scenarios of where a user could have misentered data to make sure that for every one of those, there would be a corresponding note to fix it. That meant that I had to spend a bunch of time thinking about where to write the errors in the code so that they did not interfere with the calculations. However, while it was less complicated, what probably took the most sheer time was the answer explanations, as I had to make very long strings of text that were broken up by variables, and for each of the 16 different calculation scenarios, they had to be different. One of the things that excites me about this app is that there are a lot of other science and math units that could have similar programs. I could see developing other expansions of this app to create a broader platform that could be accessed off the welcome screen. For example, the app could be expanded to help students learn and calculate force and energy, help with balancing equations for chemistry, or factoring quadratic equations. So hopefully, the Dragon and I will be back with more ways to help students learn in this virtual school environment.